Okay, so we're going to do a quick example based on the previous problem that we just did. The only difference is I tell you that the sine value of a function is negative 5/13. And remember, sine is opposite over hypotenuse, so the negative always goes with the side with the opposite side, the radius, right? So this is opposite, and that is the radius or the hypotenuse. Okay? So that's R for radius. It's in quadrant 4. So basically what I do here is I'm going to draw two pictures. I know I have some sort of angle rotation that's ending in the fourth quadrant. So then I can just draw my triangle. So I kind of actually skip that step, and what I just end up starting to do is, well, I know I'm going to use a triangle to solve this. I know it's in the fourth quadrant, so I draw my coordinate system, I draw a generic triangle, and I know that this is always the angle, right, that we're going to be working with. So here's my rotation, but this is always the perspective of this angle right here. The one that's connected to the origin is always the perspective of SOHCAHTOA. So I know the opposite is negative 5. So I'm going to go ahead and draw in the negative 5. I'm going to plug in 13. And if you know your triples, which is nice, this is 12. Okay? So we're going to go ahead and we're going to just find all the 6 trig functions. Let's say you didn't know that that side was 12 before we do that. I could use Pythagorean theorem. So that's a triple, so that's how I know it's 12. Or Pythagorean theorem, which is a squared plus b squared is equal to c squared, where a and b are two sides of the triangle. Well, I have negative 5 as one of the values, and I don't know what the other side is. So I know it's going to be positive, so I just put a positive in there. And that would be b squared. 25 plus b squared is equal to 169. And b squared is equal to 144, and so b is going to equal 12. And so now I can do all 6 trig functions. So sine, we already know. Let me erase this because I want to put the thetas in there. So sine of the angle is going to be negative 5 over 13. Cosine of the angle is going to be 12 over 13. Tangent of the angle, which is opposite over adjacent, is going to be negative 5 over 12. And then I just flip them. So now that I have the 3 main ones, I'm just going to find the reciprocal. So cosecant, which is the reciprocal of sine, is going to be a negative 13 over 5, or negative 13 fifths. Secant, which is the reciprocal of cosine, is going to be 13 over 12. And cotangent is going to be a negative 12 fifths. And these are my 6 different trig values. Okay, and these are the exact values. I'm writing them as a fraction. So when you give these guys to me, you need to give them to me as a fraction. These are the types of problems you're going to have to do these without a calculator. Okay? One thing that I would like to do in a separate video is talk about some basics where we can kind of look at our opposite over hypotenuse and think of them as x and y as well. But this is just a quick another example, like the previous problem where we just have to draw a triangle, label it, and find all the 6 different trig functions.